Moving on to page 98 here, we're going to start talking about the time value of money. So here is an investment, initial investment of $2,600, and then 5-year increments, how much that investment is worth. So if we have the year after and then the amount that is invested there, I type these into my data here and ran my scatter plot, and we can see it kind of slowly increases, and it's increasing more and more. So that type of function is going to be exponential growth. So we talked a little bit about this in module 6, and we're going to continue talking about it here. So we should remember that we're able to find the regression equation on our calculators there. Going to exponential regression, you make sure we're using L1 and L2. I would love to store that into Y1 by hitting alpha trace, enter. And then we have our equation here. So approximately, we have that 2599.86, which we can say that's about our starting value of our 2600. So 2599.86 times 1.0425 raised to the x power, and you can see how that is a very good model. So what we can learn from this is in number 4 there, the interest rate. So our interest rate, the rate of increase, how much money extra we're making every year, comes from this 1.045. If we remember, we had b equals 1 plus or minus our rate, and this is our b value here, and it was a plus because it is exponential growth. So we know that 1.0425 equals 1 plus our r. So when we subtract 1 from both sides, we know that our rate is 0.0425, which means our rate is 4.25%. And then we can, so that's a good thing to know there. And then we can use the model to figure out how much the account has in 50 years. This tells us that our time in years is 50. So I can either go look at my model, 2599.86 times 1.0425, and raise that to the power of 50. Or I can look at my table where x is 50, the y value corresponding. Let's see how quick I can get to 50 here. Ignore that y3. Let's just ignore that y3 for you. And we're going down to where x is 50. We get about 2,835. We scroll and highlight that over. We can see the decimal place is 0.43 as well. So it should be 2835.43. Number 6 just has a quick question. What's the interest rate of this equation? So just looking straight there, you should be able to see that's 0.095, which is 9.5%. I kind of did the same thing I did up here on 4, where I subtracted 1 and then moved the decimal place over twice to get our percentage. So this is just a general exponential growth of our interest rate here, where FV is how much the account will be worth. T is time in years. I is our interest rate, has to be in decimal form. PV is principal or present value. That's how much the account is currently worth. Sometimes we call that the initial investment. Now our account can be compounded annually. So that's once a year, or as we'll see on the next page, you might see a formula that looks kind of familiar to you. Some investments can compute quarterly, monthly, or more. So annually, that means once per year. So the number of compounding periods per year is once. Semi-annually, that will happen twice a year. Quarterly will happen 4 times a year. Monthly happens 12 times a year. Daily happens 365 on average days a year. So with that compounding happening where they run the percentage and you get extra money more often, that adds these ends to our formula and kind of complicate them a little bit. So we'll apply that to these two problems here. So suppose you invest $2,600, that is our initial investment, our present or principal value, into a savings account, and we have our interest rate here. So that tells us that I is 0.0425, and that compounds quarterly. Quarterly tells us that our end value is 4 for the number of compounding periods is 4 times a year. And we want to determine the future value. We want to determine our future value in the account after 5 years. That tells me my time is 5 years. So my future value will be 2,600. I'm just plugging it into this equation right above. 1 plus 0.0425, the interest rate, over quarterly, 4 times a year, raised to the power of 4 times 5. And when I type all that into my calculator, we get 2,600, 1 plus alpha y equals enter to get our fraction bar, 425 over 4 raised to the 4 times 5. Get about a little over $3,000, 3211.99. Another example here, we have our initial investment of $3,000. That's our PV. Our interest rate here is going to be 0.053. Our time is 50 years, and we want compounded monthly, where N is 12. So our future value, initial investment, $3,000, 1 plus 0.053 over 12 for monthly, raised to the 12 times 50. Let's see how much money you would have. So we take the $3,000 initial investment, 1 plus 0.053 over monthly, raised to the monthly times 50 years, about $42,000. Come back next video, we'll talk about finding how much you need to invest, the initial value, the present value, to figure out how much money you will have in the future. Then shortly after that, we'll go to a fun little program calculator, some apps you can use to do this a little quick.